In the last video we talked about critical numbers, and in this video we're going to review a couple topics from pre-calculus and give some more definitions and talk about things in a little bit more of a calculus context. So from pre-calculus we already know what the ideas of local min and local max are. So we say there's a local min or a local min or max at x is equal to c, okay, so it occurs at an x value, and the local max or min is actually a y value, okay, as we see over here. But a max is if we can determine a value such that it's higher than the rest. So think of this as just a hill, okay, so this is going to be say f of c, and so if we look around it, okay, again for all x near x is equal to c. Okay, so this would be x is equal to c down here. If it's higher than the rest, then it's a max. Okay, so graphically, higher than the rest, a peak, if you will. A min is, well, if it's a minimum, it should be lower than the rest. So think of the bottom of a bowl. Okay, so this is x is equal to c, and this, the y value, again, the y value is the local min. Okay, so again, locally we're looking near. Now the other type is a global, or we also have used the term absolute. So this just means it's higher than the rest for all x values. Okay, so if we look at the entire function, it is the absolute, it is the highest value occurring for a maximum or lowest value for a minimum. Okay, nothing too surprising. Now, one important idea to keep in mind is that if you have a global max or a min, they are also local maxes or mins, not the other way around. Okay, so if it's the highest on the whole thing, it's certainly going to be highest in a small area. Okay, and then so here, this is the same graph we saw before when we were studying critical numbers. So now I've just added some endpoints, so we're on a closed interval, okay, and we want to determine the local min or max as well as the global max or mins. Okay, so we said our critical numbers before, or our critical points occur at or occur when x is equal to minus 3, x is equal to minus 1, x is equal to 1, and x is equal to 3. Okay, and actually now, since we are on a closed interval, I'm actually going to use, I can include the endpoints. So I'm going to also include minus 5, and I'm going to include positive 5. Okay, and I'm going to use blue to determine whether each of these are a local max or min. It is a property that all critical points are usually either a local max or a min. There are some exceptions, and we'll see those when we actually discuss the first derivative test in the next video. Okay, but for right now, we're just going to go with that idea. So if we have a critical point, it's going to be either a local max or a min. And we also have to include endpoints. So here we go through and we look at negative 5, okay, and we look around it. There aren't any other higher values, so I'm going to say that this at negative 5 I have a local max. Okay, and I progress. Okay, continuing going left to right. I look. Well, negative 3, at x is equal to negative 3, there are no other values lower than it. So I'm going to say at negative 3 there's a local min, sorry. At negative 1 we have a local max because it's higher than anything near it. So this is the local max. Going negative 1, or at positive 1, it's lower than anything else around it, so this is also a local min. X is equal to 3 is going to be a local max. And at x is equal to 5, this is going to be a local min. Okay, so I've determined my local extrema. So this part is done. Next, I want to determine the global or the absolute min or max. And since we're on a closed interval, and we'll see this property in just a second here, we are going to have an absolute min or a max. Okay, so looking at this entire thing, what is the highest y value that I attain? Well, the highest y value is 5, but where does it occur? It occurs at -5 and at 3. So actually, I can have two places where I have an absolute max, but the absolute max is only one value. So this is also an absolute max, and also at -5. Okay, now what's the lowest value that I attain? Well, that's going to be at the lowest value is -3, and that occurs at +1. So this is also an absolute min. Okay, so graphically, this should be relatively straightforward. What's the highest value? What's the lowest value for absolute or global min or max? And then for locals, just look in a small area around it. Okay, this should be reviewed from pre-calculus. Now, when we talk about all of the mins and maxes together, whether they're local or global or absolute, we talk about them being extreme values. And typically, if you hear the word extrema, that's the plural form of extreme values. Okay, so for example, you might see a problem that says classify the local, or classify, or find and classify the extrema of the function. Okay, and this I kind of let slip before, but there are certain occasions where we have global extrema. In some cases, we won't have them. But if we have a continuous function, okay, so remember continuous, you draw it with your pencil without lifting up, defined on a closed interval, then the function attains a global min and max. So global extrema exist for sure on a closed interval. Okay, there are other cases where you do have a global extreme value, but in general, this is a good catch-all. Okay, but now we want to try and determine all this algebraically, because remember, we want to be able to do everything on a graph, algebraically, and tabularly. And tabularly, we're not going to do because it takes a long time. But we just, on the previous slide, we actually went through how to do it graphically. And in the next video, we're going to talk about the first derivative test, which allows us to do this. But again, as I kind of mentioned, they occur at critical points, and if we're in a closed interval, at endpoints. Okay, so in the next video, we'll explore how to do this in more depth.